Saxon Advanced Math, Lesson 16.b. These are abstract equations. Now, they're going to use a little bit of a trick, if you will, and I'm going to show that to the right first with real numbers, and then we'll get to the abstract in just a moment. If I took an equation like this, and I don't want to have to deal with subtracting 2/15 from both sides, finding a common denominator, and then multiplying both sides by 3. It's a whole lot easier if I can clear the fractions. Well, how do I clear fractions? Well, I multiply everything by whatever a common denominator would be, and it automatically clears the fractions. Well, if I look at 3 and 15, the common denominator is 15. So if I multiply the whole thing by 15, I will eliminate all fractions. And some of you have seen this before. If I'm 15 divided by 3 is 5. 15 times 2 divided by 15 is 2. And then 15 times 2 is 30. And now I have this equation right here, which is a lot easier to work with. Subtract 2 from both sides, that gives me 28. Divide both sides by 5 and get 28 over 5 is what x is, and that works out. Let's work with that on 16.3, that idea, and we're going to be solving for the abstract, which is we're solving for c. Now c is in like the hardest spot to get by itself. Right here it is, way in the denominator, far right, and I want my answer to say c equals. But I have y equals v, a over x, plus b over mc. The first thing that they did is they went ahead and multiplied everything by v. And I'll show you in just a minute another way to do this. But multiplying everything by v gives me a v up here and a v here. Right? That gets rid of my denominator. By doing so, now I have this y equals, but I still have an mc in the bottom. We're going to use this tool right here and say, what if would I multiply this by to get it all the denominator gone? Well, if I multiply by xmc, I would have no denominators. I wouldn't be working in fractions at all. So I go ahead and do so. I multiply everything by xmc. That gives me xmcy, xmcav, right? And xmcbv. That would be there. Then I cancel anything out that I can. There the x's are going to cancel, and the mc is going to cancel, and that leaves me with this. Here's our promised equation, no fractions. Now, what are we trying to solve by itself? Well, c. But I have a c on both sides. So I need to move everything that doesn't have a c e on the right and everything that has a c on it on the left. So I subtract an ac and v from both sides, right here, and that leaves me with this equation. At this point, because c is what I'm trying to isolate, I factor the c out to the front, leaving me with mxy amv. Okay? Now I have that as being multiplied by c, so if I do the opposite of multiplication, division, I divide both sides by this. That gives me bvx over mxy minus amv. And I have what c is. Now, I want to show you, just if you look over here, this is the same equation, same problem. I'm just going to attack it a little bit differently. So what I'm going to do for this one instead is because of this v right here, I just divided both sides by v, giving me y over v and then the ax plus b over mc. Same idea. I believe it looks easier to me when I don't have to put the v's in 2 if I don't need to. I look at the common denominator, vxmc. That's what the common denominator is. So I multiply everything by vxmc. That's going to give me yxmc, avmc, and bvx, because it's canceling out the x, the mc, and the v out of each one of these respectively. At this point, both the c is on both sides again, so I subtract that from both sides. That gives me this. I factor the c out to the front, right? Take a c out of both terms. And I have mxy minus amv in the parentheses. I don't want it over here, so I divide both sides by it, and I end up with c equals bvx over mxy minus amv. It works exactly the same way. Feel free to use either method that you'd like, although this is abstract equation because we are solving for a non-real number or a non-specified number. We're solving for a variable instead of solving for a number itself, especially when the variable is stuck inside of a problem with no actual numbers.